Hello, my name is Alan Crossland and I'm Managing Director of PointScan Limited. I've spent over 20 years in operational and project management, predominantly within the water industry, and have been involved in a number of major construction and engineering projects throughout the UK. Throughout this time, one of my biggest frustrations when working on projects of any size has been how to overcome inefficiencies, program delays and reworks which occur throughout the project delivery process. I've seen many developments introduced over the years. Some have stayed, some have fallen by the wayside. So when I was first introduced to 3D scanning systems, I too thought it was another one of those fly-by-night processes that would fade into the past like many others. I certainly didn't think it would have such an influence over my career. However, the more and more I've become involved, the more and more I've found ways of utilising the technology, not just as a design tool, but as a visual aid for developing project delivery. For any of you that have delivered a project and had plant clash with pipework, access problems, errors in design, and reworks on site, you'll know and understand the frustration and, more importantly, the costs, not only financial, but against program delivery and client credibility. Well, I've found that by introducing 3D technology as a project delivery tool, I was minimizing redesign and construction reworks, and selfishly meant that I was no longer requesting additional funds at project reviews, but providing financial efficiencies and project savings. For those of you who attended the recent event at Reading, you would have noticed a scanner at the front of the room. So before I begin, I just wanted to demonstrate how quickly data can be acquired from site. As the scanner rotated, it was acquiring up to 970,000 points of information per second. This data was then converted into a measurement and built up a 3D image of its surroundings. As you can see from the video, in this case, after a simple registration process, a 3D image was created of the conference room. The scan duration was 3 minutes 15 seconds, and in which time the scanner recorded over 27 million points of data. The scanner does work on line of sight, so in this example it would appear that there's areas of information that are missing. However, this is easily rectified by completing scans from multiple locations. So even raw scan data, as you can see in the screen, can provide a graphical representation of the room and its contents. And this information can be interrogated to take measurements, volumetric data, as well as full color imagery. The point cloud data is also supported by higher quality images which can be viewed through the planar format. Coming from a project management background, I wanted to show how 3D laser surveys can benefit project performance rather than just being a tool specific to the design and CAD teams. Making changes to any process or procedure shouldn't be taken lightly. But a wise man once said, if you do what you always did, you will get what you always got. So I believe there's 3 simple questions that should be asked before making any changes. Can it be done better? Can it be done more efficiently? And can it be done safer? So can we improve on what we're already doing? Well, they say a picture paints 1,000 words, or in this case I should say numbers. And there is no doubt that a 3D scan captures more data than a traditional manual survey. But it is the utilization of that data that improves this technology over traditional methods. As with a traditional survey, 3D data has the capacity to provide information for the design and CAD team. But it also creates opportunities for the entire delivery team to visualize the project. This encourages early development, and by immersing yourself in a 3D environment, it becomes easier to identify potential problems and design changes when compared to 2D drafting data. More importantly, it means that you can bring the project site to the office and share it throughout the project and delivery team, and therefore minimizing any further costs or delays incurred by site revisits. We have proved that 3D laser scanning can reduce on-site data collection times by up to 80%. And because the data is so accurate and instantly available, design programs can also benefit, especially with no need to return to site to collect additional data. And with the final design now free from error, you can minimize any need to make costly changes during construction. It is important to remember that by using this technology, we are saving costs that you do not necessarily budget for. Program delays, reworks for example. The real cost comes in delivering the project right first time. Okay, we already know that we can reduce the amount of time we spend on site, and statistics show that the less time on site, the fewer incidents and accidents are recorded. But due to the capacity of the scanner, we can also capture data from up to 330 meters, which gives enough flexibility to take site measurements from the ground or at least a safer area on site. This means that there's no need for expensive access equipment or working at heights. Further risk can be reduced by remotely accessing the scanner, again from a safe location. This allows for the entire delivery team to have access to restricted areas from the safety of an office environment. We all know that technology is continually improving, and we are committed to providing the latest in equipment. I've already mentioned most of its capabilities, but an important feature is the GPS, which allows us to geo-reference the scan data with local and global coordinate systems. I wanted to finish with a case study completed for FSD at Basingstoke Wastewater Treatment Works. FSD were contracted to install pipework across the site, and as you can see, it's a very labour-intensive process. Before any manufacture could take place, dimensions needed to be verified against the original model, and it was noted that there were variations. We were asked to attend site and complete a laser survey. The objective was to record the location of known flange faces from across the site to enable the manufacture of the pipework. The site was approximately 7,000 square meters, and 38 scans recorded over 475 million points of data within an 8-hour period. The overall accuracy of this project was 4.6 millimeters, which was well within the tolerances agreed with our client. So by completing the 3D laser survey, we identified 54 individual flanges on site. These were then recorded in 3D space. This information was imported into FSD's modelling system, and they were able to create and design their pipework based on the information provided by the 3D scan. This allowed the manufacture of pipework to be delivered to site and fitted error-free. This slide shows how easy it is to take measurement information from the 3D scan data, in this case taken from the planar view. It's also interesting to note that by the time this scan was completed, it was early evening and the site was in darkness. But because the scanner does not need natural light, it easily identifies the location of the pipework. The 3D laser survey provided a number of solutions on this scheme. From the provision of accurate survey data, the pipework was designed, manufactured and installed error-free. So, how did we do? Well, I believe we've done it safer. We've reduced the amount of time that the survey and installation teams have spent on site and minimised any working at heights. We've done it more efficiently, again by reducing time and eliminating reworks. And I believe we've done it better. We've increased the data capture, we've shared the information with the project and delivery team, and we've given confidence in design and customer satisfaction. I'd like to thank you for taking an interest in watching this presentation. Should you have any further questions, please feel free to contact me at the address shown on the screen. Thank you.